Okay, we're looking at the one sample t-test. Okay, and in this one, we are delving into the test value because this is real important as we move through some of the rest of the tests that we're going to run. The test value, again, is what in a one sample t-test we have the mean, and then we have a test value. Okay, whatever that number is. Okay, we're going to use that test value against the mean to see if it's above or below the mean. Okay, this one we're looking at the mean versus a test value. When we move to the next test, we're changing directions and we're going from there to looking at the difference between two. So you look at the difference between two means individually between themselves, and then you look at each mean versus that test value like a one sample t-test. Okay, but right now we're looking at a mean for the one sample t-test versus a test value or a criterion value. I like test value, it's easier to remember. Okay, the test value is the constant in which we will examine the data to see if it is above or below the mean to make a decision, basically a conclusion. Here's what the box looks like. You'll see the test value right here in this box. Okay, we went with a 15. Okay, this is for choking. Okay, in terms of how to understand the test value, think of it as a line. Above it's one direction and below it's another. Okay, in this case, in a lot of cases, below it would mean less than, and above it would be more. Okay, could be good and bad, could be high and low, lots of different words that you can use. So examine the box to the right, directly under the title is the test value number, which is 15 in this case. It can be 15, it could be 70, it could be 100, it could be whatever you decide it is. Okay, moving on to the next slide. Analyzing the test value. For this example, we'll be running a one sample t-test to examine how many reps a person can bench press 125 pounds until exhaustion. A one sample t-test is performed on one sample, okay, vs a test value. That one sample is generally a mean, okay? We will be examining the mean, the number of reps, versus the test value of 15. In most cases, just like the example, we are focusing on seeing if what we're doing is working. In essence, we can make decisions. So if I'm the trainer and my number is X, oh, actually, we're still going 15. My number is 15. So if I have a group of players or a group of individuals that are doing these reps, and I get it down to where, and the mean is higher than 15, well, I guess whatever I am doing to train them to get them to do more than 15 is fantastic. If it's below 15, now I get to assess what I'm doing to see if I need to push them harder to get them over that as a group over the threshold. It's not one person, but it's a group of a group of participants that I'm dealing with. So it's not just one. One could have 30 and the other one could have 0. The whole idea is when you're done, that mean has to be above or below, and then I get to make decisions from there. Give you some other examples of one sample t-test. You can look at mile times, service time. When you go into Starbucks and you look at the screen up there, and it's telling them how many seconds in drive-through versus how many seconds over here in the walk-up. How long is it taking to get them from order to there? All those numbers are basically ran in the one sample t-test, and they take all of them and they come up with a mean, and they set a time. So let's say it takes 3 minutes a person, but we really want it to be 2 minutes and 30 seconds. If we run every single time that every single customer comes through, and we run it for a day or we run it for a week, we'll have thousands upon thousands of answers. But if that mean is at below 230, well, we're on it. We got to keep doing what we're doing. If it's above that, now we have to examine the certain things of the day that we're doing that can shave off just about, let's say, 25 seconds on the day. That means sometimes they're going to have ones go long and one that goes short. Income, you can look at income, you can look at years worked, you could look at anything that's a number that you can pick a number that you want to either decide whether it's above or below that. So we're back to that same example. Staying with the same test value as 15, our example, how many reps can a person bench press 125 pounds until exhaustion? The test value is 15. This means I believe the mean of the group will be 15 reps or more. Okay? And 2 or 3 or less. We then test the participants. After testing is complete, the mean of the group is 18. Woohoo! We are strong and we are above the mean number of 15, the test value of 15. So looking at it this way visually, we pick our test value. We're picking this test value. We run our test. We got a mean score of 18, so there's a mean difference of 3 plus 3. Mean difference of 3. So our test value was 15 and our mean score reps was 18. Okay. Participants performed better than the researcher believed. Okay. That's just a general statement because it's a plus 3 and not a minus 3. It's above 15. So 15 was that line. Okay. Let's see. Pen. 15 is that line. Okay. And actually, we were above 15, so basically they performed better. If this number would have been 13, it would have been lower, and this number performed poorly. Okay? And we would have to change the words to that sentence, but it would have been different. Could have said, wouldn't use the word worse, but you say did not reach the number of 15 reps. Lots of ways you could write that. Consider a conclusion for example 1. First off, you have to understand what the test value is using. We're using 15. We then chose that test value of 15. We collected data from participants. We ran the data. Okay. We examined the mean versus the test value, and we draw a conclusion for the one sample t-test. So test value, mean score of reps was 18, mean difference plus 3. When we write it up in the conclusion, it's going to say, instead of test value, it's going to say test value in conclusion is called so it'd be the population mean. So here's the concluding sentence. Therefore, participant scores were analyzed against the population mean, and it resulted in an increase in reps. Okay? So summary. The test value is a value we give that we want to make a decision whether by the mean of the data it's either above or below. Then we have to decide which word we're going to use. Was it better? Was it higher? Was it, you're going to use a descriptive word that shows that direction. If it's below, they were let's say participants were unhappy. If we're working on happiness, or in the reps, if it would have been the reps, the participants with a population mean of 15, the overall score of 13 showed that they were not, they were well below the mean and did not perform as many reps as the researcher believed. Okay, so think of it this way. There's a line, whatever that number is. Let's say 70. If in the example that we show, 70 is a C. If the scores are a D, they perform poorly. If the scores are higher, let's say an 80 or above, they scored well higher than the mean we were looking at. Then as a teacher, in an exam score like that, I now can say, well, if I think they're all going to get C's on this test and they got B's, either my test was too easy or they're understanding the material at a high level. They're understanding what I want them to learn. If it's below, Now, is it my teaching, or did they not study, or any other variable that might mess up that score? And then I have to make a decision if I'm going to change what I'm doing. High, I may want to change the test and make it tougher. Below, I may have to make the test easier, or I need to teach it better, or find out what's going on with the student to create such a bad score. Okay, this is the end of the test value.